Well, there we're back. Hey, look what time it is. 4:58. Been up for about 20 minutes. Took care of the dogs. Got myself some coffee, because God knows at 4 o'clock, 4 whatever in the morning, it's going to need some. All right, kids. Here we go. We're here for Algebra 1, Common Core, the double C's, January 26, 2015. If you're not here for that exam, well, you're in the wrong place. Mr. Key is here to help you. In this video, we will be doing part 1. Problems 1 through 12. You can see an organized list of all the videos for this at www.Mr. Krause. I think this is the neatest I've ever written this. Math.com. Now, there's also going to be linked down somewhere down there in the show notes, so you can click on that as well. Somewhere over probably about here, there'll be a button that says subscribe. No, maybe it's over there. I'm not really sure actually where it is. I have no idea. There's a thumbs up button. Hit that too. You can hit the comment button. You can do just about anything you like. Here's what I don't want you to do. I don't want you to be here if you haven't tried these problems on your own. You need to struggle. You need to be mad. You need to attempt these problems on your own. Get angry. If you go to my website, mrcrossmath.com, click on the Regents Review. Make sure you click on for Algebra 1, not Algebra 2. And on there, you'll see a link for the, see a link there for the actual test. And on the right, you'll see a link for the multiple choice answers, not solutions or all that stuff, just answers. And then you'll see 3 video links, 1, 2, 3, problems 1 through 12, problems 13 through 24, and then 25 through, I think it's 37. The reason I do this is just because it's easier for me and it's easier for YouTube, and it kind of gets things a little bit more organized. That way you're not sitting along for an hour-long video if you only want to watch a couple videos, a couple of movies or shows. But anyway, they're all there. So hopefully you're here to actually work, and hopefully you're not here to cheat, but we're ready to get going. We, as in me and you. I don't have anybody else with me. There's nobody else around. All right, so the owner of a small computer repair company has 1 employee. He pays them an hourly rate of $22. Anytime it's a per hour or per something, that's always going to get multiplied by something. And you'll see right here, we're multiplying 22 by X. And if that's an hourly rate, 22 by X, he estimates that his profit using this function, it's going to be $8,600 minus 22 times X. So in this function, F represents, well, clearly if $22 an hour is his hourly rate, X has to represent the number of hours worked. There she is. Done. Peyton is a sprinter who got to have some coffee. So we want to convert from a 40-yard dash. This is 40-yard dash in 4.5 seconds to miles per hour. Whenever you want miles per hour, when you're done, you need miles on top and hours on the bottom. That's what we got to get. Oh, so which ratio is incorrectly written to convert speed? Let's see. Yards will cancel. Feet. These feet are not going to cancel with these feet, and I need miles on top. This one looks to be backwards, because I need miles on top. Let's see. These seconds cancel with these seconds. These minutes cancels with these minutes, and I have hours on bottom, but I can't get rid of feet, and I don't have miles on top, so that's got to be the one that's bad, right there. Ka-ching! Moving on, children. Which equation has the same solutions? All right, I'm going to do this one 2 ways. I'm going to do it the mathematical way, which is to just factor it. So, by the way, if you're here to actually get better at math, sometimes what you want to know is how to do a problem 1 or 2 or even sometimes 3 different ways. If you can do a problem 2 ways and get the same answer, there's a really, really good chance you got that right. And that's exactly what you want to do on the Regents exam. You want to know for certain, ka-ching, star that one, did it 2 different ways, I know it's right. So don't always just look for the right answer and see what I came up with. See if there's another way to do it. Spend an extra 30 seconds with me on each problem to see if you can figure out another way to solve the problems. The only way to get 2x squared is got to be 2x times x. And you'll notice they're all that. They're all that way. I know the only way to get negative 3 is to multiply 1 times negative 3 or negative 1 times 3. The key is they got to be of different signs. One's got to be positive, one's got to be negative. So one's positive, one's negative, one's positive, one's negative, one's positive, one negative, one positive. So that's not going to help us out. So now what we got to do is figure out where to put them. If I put the 3 here, I'm going to get 6 and 1. That'll never give me this 1 that I need in the middle. So the 3's got to go. The 3 has to go with the 2. So let's eliminate down that. That 3 has to go with the 2. So these 2 have to go. And then I want positive x. So the 3 has to be positive and this has to be negative. Because this will give me negative 2x. And this will give me positive 3x. And that'll give me the right one. So it's this one. Choice 4. Now, that's the first method to solve this. The second one's even easier, I think. I think doing this other way is even easier. We just go into graph mode. And you type in 2x squared. 2x squared. You got to type it in right, which shouldn't be a challenge. But for some students, for some reason, it is. And you graph it. You get a parabola. Now, be careful. The new one I'm going to graph is going to graph right over it. So I'll show you a way to show you what it looks like. So that one is 2x plus 3. 2, oops, not 2, but x minus 1. That's what we came up with, right? Yep. Watch the blue. It's going to go right over it. Now it's red. And you can always hit, on this calculator, hit the tab button and say, okay, I don't want this one. I don't want this one. I want it. I don't want this one. I want it. See how they're right on top of each other? That's another indicator. Now, there's one last way to do it. There's one last way to do it. You could go through all of these and double distribute. So that would give me 2x squared. This would give me minus 2x. This would give me plus 3x. And then minus 3. And notice these two make positive x, which gives me back that problem. So there's 3 different ways to do that problem. Quite frankly, graphing's probably the easiest way. All right, so Crystal was given $3,000 when she turned 2 years old. Yay, she's 2 years old. So this is our principal amount. 2%, remember 2% is 0.02. That's 2%. Be careful with 2%. Luckily, they got all of them as 0.2. Now, if you're putting money into an investment, you want that investment to grow, which means we don't want negatives. Negatives don't make any sense to me. So we're going to start with $3,000. $3,000. And I want to know what it will be when she turns 18. Now, that's very tricky. A lot of kids are going to like, oh, I see an 18. Oh, I see an 18. Oh, I see an 18. No. It's when she turns 18, but she started when she was 2. So the time there is 18 minus 2, or 16 years. Just because the 18 doesn't stand for how old you are, because, like, I'm almost 50. So, like, what? Can I put my money in for a year and say, oh, I'm 50. I want it as if I put it in for 50 years. No, that doesn't make sense. So here it is. And there's only one way to do this problem, just to kind of think. You got to use your brain. Brain. I don't even know what a brain is. There's 2 ways to do this problem, but the second way is a little bit time consuming, and that would be to kind of just draw negative 1, negative 1, negative 3, 0, negative 2, 1, 1, 2, 6, 3, 13. Kind of looks linear, but it's not. See the separation between these two? The other way to do it is just to say, oh, I'm adding 1 here. Oh, I'm adding, what am I adding here? I'm adding 3 here, I'm adding 4 here, and I'm adding 7 here. In order for it to be linear, it has to add the same amount. Let's check this too. This one over here. Negative 1, negative 3, 0, negative 1, 1, 1, 2, 3, 3, 5. That one looks pretty linear. That one looks pretty linear. Let's check. Add 2, add 2, add 2, add 2. There she is, kids. And if I check the other two, just for fun, I don't deal with fractions. Add 1. I mean, this is adding a half. Add 2. Add 4. See how we're adding different amounts? Nope. Add 1. Add 1. Add 7. Add 19. What the heck is that thing? I don't even know what that is. So 2's the answer. There it is. Or 3's the answer. There it is. Which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? What? Let's think. Whoa. Trying to trick you here, kids. Not really. It's actually a very easy question. So, like if you were going to go in and go, I think that house has lots of kids in it, so I think they will have 5 devices. That house has a couple of elderly folks, so they may only have 1 device. Kind of makes sense, right? Would you say, I think that house, which has 5 kids in it, I think they'll have 4.8 devices. What? How can you have a 0.8 device? I know you guys with those iPhones and your cracked screens and all that craziness. That's still a device. It's still a whole device. It may not work like a whole device anymore, but it's still a whole device. Would you say to your, like, when you're, oh, hey, look, there's 3 kids in that house. I think they'll have 7.149862475434. No, that doesn't make any sense. So irrational makes no sense. Rational also doesn't make sense. Rational are positive and negative whole numbers. Don't care about those. Integers. Now, integers are positive and negative whole numbers. Can you have negative devices? Like, oh, wow, they've got only 2 grandparents live there. I think they have -6 devices. No, that doesn't make sense either. The only answer that actually makes sense, and it's kind of, you got to think about it, whole numbers. Whole numbers are 0, 1, 2, 3, and up. Now, they really weren't that bad, because if they were that bad, they would have put natural devices. Natural devices, if they said natural numbers start at 1, and you go 1, 2, 3, and then you'd be like, oh, is it 1, 2, 3, 4, or is it 0, 1, 2, 3, 4? And then in that case, you'd still have to pick whole numbers, because 0 still could be a possible answer. You can have people that have no connected devices at all. Maybe not today, but whatever. Let me write this off to the side. 7, I'll use my space over here. I'm tired of the red pen. 7, oh, I don't really want to highlight it though, minus 2 over 3x less than x minus 8. All right. So as I look at this problem right here and I say, whoa, wait a second now. That looks pretty complicated because of that dumb fraction. Oh, wait a second. I have a math helper, Mr. Krause, that says if you multiply by the denominator, notice there's a denominator of 3 there. If I multiply both sides by 3, or in other words, I multiply everything by 3, that fraction will go away. By the way, I'm going to do this another way too. So if I do that, this gives me 21 minus, the 3's cancel, 2x less than 3x minus 24. Everything gets multiplied by 3. Okay. Now I just work. Add 2x, and I get 21 is less than 5x minus 24. Add 24, and I get 5x is greater than 45, or x is greater than 9. And there's my answer. X is greater than 9. Now, having said that, I can do it a different way as well. Let me do it right up here. 7 minus 2/3 x less than x minus 8. I can do this because I have a doggone calculator. I'll add 2/3. Now, this is the hard part. 2/3 x. I have to add 1 plus 2/3. Now, if I do that on my calculator, because I have a calculator to do that, 1 plus 2 divided by 3, 5/3. So I get 7 is less than 5/3 x minus 8. I'll add the 8, so I get 15 is less than 5/3 x. And then I'm going to divide by 5/3. You got to be careful here. If you do it this way, it's wrong. 15 divided by 5 divided by 3, it'll give you the wrong answer. See, because it's 15/3 divided by 3. That doesn't make any sense. So what you got to do is control division. 15 over control division 5 divided by 3. Oops. 5 divided by 3. Enter. And 9. So you get 9. 9 is greater than x, or x is greater than 9. Just be careful. Oh, I circled the wrong answer. Oh, crazy, man. X is greater than 9. This is the right answer. By the way, if you're on this problem, go back and check. I corrected the answer. I corrected the answer back up here. The answer should be number 1. So if you came to this problem and you didn't look at this problem, it should be number 1. Made a mistake there. Anyway, need more coffee. The value in dollars of a certain car after X years is represented by this equation. To the nearest dollar amount, how much more is the car worth after 2 years than after 3 years? So what we're going to do is we're going to plug 2 into this equation, and then we're going to plug 3 into this equation, and then we're going to subtract. So let's do that. 25,000.86. So 25,000 parentheses 0.86 raised to the second. 18,490. 18,490. And then I'm going to go do it again. Same thing, but so I don't want to retype that. I'm lazy. Put a 3 in there. 15,509. 15,509. Something like that. So then I'm going to take this. Enter. And I'm going to subtract off this. Enter. And I get 2589. There it is. Done. Which function has the same y-intercept of the graph? Well, this y-intercept is -3, and it has a slope of 2 over 1, or just 2. Well, okay. I don't know if they're going to ask that. Whoa. Which equation has the same y-intercept as the function below? So this one, if I split this one up, I get 12 over 4 minus 6 over 4x. And this is +3, so that's not going to work. This one, if I bring the 27 over, I get 3y equals 6x minus 27. Divide everything by 3. That's 9. That's not going to work. This one here, I've got 6y equals -x plus 18. What I did was bring this x over, put it in front. Divide by 6. That's +3. Well, it must be this answer. So what? It can't be that easy. Subtract 3, subtract there. Y equals 6x minus 3. Now, it didn't say which is the equation of this graph. It said which one has the same y-intercept. That one does. Choice 4. Moving on, children. Moving on. Going on to the next page. What do we got left? Woo! 3 problems left. Let me get this blown up. All right. Fred. Good old Freddy. Freddy is a rectangular piece of paper. The length of Freddy's paper is represented by 2x minus 6, and the width is represented by 3x minus 5, and the paper has a total area represented by... Wow. What a great question. So area is equal to length times width. So we'll take the length, which is 2x minus 6. And we'll do the width, multiplied by the width. We get 3x minus 5. Now we got to multiply them. So these multiplied to give me 6x squared. That means you guys are gone. These multiply together give me positive 30. There's my answer. But I could finish it. This is negative 10x. This is negative 18x. And those make negative 28x. Done. That problem was dumb. This problem, however, is not the easiest. Here's what I would do on this problem. And I even think this might be difficult. I'm going to go over to my graph paper, which 311 and negative 2, 1. Let me blow this up so you can see it. So, I think it was. My points were, oh no. Shoot, I don't remember what page I'm on. Let's go 6. Let's go 5. 311 and negative 2, 1. Why do I keep doing that? 24. So, see, that's what I hate about this thing sometimes. 311, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And shoot. Negative 2, 1. Negative 2, 1. So if I graph these, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So it's going up 2 and over 1. So that's the line graphed by those points. The other points were 2, 1, 2, 4. 2, 1, 2, 4. 2, 6, and 2, 9. 2, 6, 2, 9. So they're basically just saying at 2, what's the number, right? So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 9 is the winner. 2, 9, chicken dinner. Now, that's the mathematical kind of cheating way to do the problem. I can just use my I can use a piece of graph paper. They do give you that graph paper at the end of the test, so use it if you want. The other way to do this is a little bit more difficult, but I want to show you anyway, because some of you like this. Will like this way. We'll do the slope, which is 11 minus 1, change in y's, over the change in x's, 3 minus negative 2, which is 5. So my slope is 2. Then you'll create the equation using this. Y minus y1 equals slope x minus x1. You probably have seen this formula before. So y, and I'll pick one. It doesn't really matter. I'll just pick this one. Y minus 11 is equal to 2 times x minus 3. Moving over to here, I get y minus 11 equals 2x minus 6. Add the 11, I get y equals 2x plus 5. So that's the equation. And basically what they're saying is plug in 2 and tell me what you get, because all the x values are 2. So if I plug in 2, I get y equals 2 times 2 plus 5, and there's your 9. So there's another way to do the problem, especially if that was a part 2 question. You'd almost have to do it that way. All right, last question. Let's move. How do the graphs of this and this compare? I wonder if I can do this on the graphing calculator. I'm going to do it by hand first, okay? And then I'm going to do it by, see if I can do it on the graphing calculator. So f of x is equal to 3x minus 2 squared plus 1. And g of x is just equal to x squared. So let's look at these. This 3 makes it narrower. A normal parabola goes up like this, something like that. But when you have a 3 out in front of it, it gets it a lot steeper or narrower, much narrower. By subtracting 2 here, what you are doing is, remember, these are horizontal shifts left and right, but backwards. So by shifting this thing, you're moving the vertex right 2. And by adding 1, you're moving the whole thing or the vertex up 1. So which one is narrower? So we don't want wider. We don't want wider. We want narrower, and its vertex is moved right 2 units. So this would be the right answer. Now, I think we can look at this graphically as well. Since we got a little bit of time, you got no place to go. Let's look at just x squared. Here's x squared. Boom. So now let's hit tab, and we're going to go 3 parentheses, x minus 2 squared plus 1. You'll notice it got narrower. Look how skinny it got. It moved this vertex to the right 2 and up 1. So you could look at it graphically as well. All right, there it is, kids. That's it. We're done. Yay. Hit the subscribe button. Hit the like button. Tell me how much you love these videos. By the way, if you do get 100 on the video on your test, I really want you to email me at kenkrause@gmail.com. Should be pretty easy to find it, or just hit me up in the show notes or hit me up in the comments section. And but I'm going to ask you that you provide proof, but you will go on my Hall of Fame. So if I've helped you in any way get 100 on your Regents exam in Algebra 1, hit me up on that and provide me with proof, a quick photo screenshot of your score online, or a picture of your report card, or something to that effect. All right, kids, that's it. We're out. See ya. Catch you on the flip side. Bye.